Welcome to your video for lesson 3 in unit 7. We're going to be multiplying polynomials today. So yesterday we added and subtracted. Today we're going to be multiplying. So in the first example you see we have the monomial 3x multiplied by the quadratic trinomial. Again, it's quadratic because the degree is 2. It's a trinomial because there are 3 items. You know, the leading coefficient is 2. And so we want to multiply these two polynomials together. And to do it, it's very similar to multiplying with a whole number times a group of different terms. So I'm going to multiply 3x times 2x. So when that happens, I get 6x, and when I multiply by the same base, I add the exponents to the third power. 3 times negative 5 makes negative 15. X times x makes x to the second power. This is the most commonly missed one. People forget that there are ones here, so I must add them together when I multiply by the same base. 3x times positive 3 is positive 9x. And there you have it. I've multiplied the monomial 3x by 2x squared minus 5x plus 3. The same thing can happen over here, except now you notice the monomial is on the right side. I have a binomial that's linear because it's degree 1, 4x plus 7, multiplied by the monomial that's linear, negative 2x. I can distribute backwards if I have the single-termed expression on the right side. Negative 2 times positive 4 is negative 8. X to the first times x to the first makes x to the second power. Then I must distribute negative 2 times positive 7, which makes negative 14. And x to the first times literally x to the 0 would just be x to the first. And that's my answer when I multiply on the right side. Sometimes, though, I have a binomial times another binomial. I have 2 items in the first grouping and 2 items in the second grouping. So in this case, what I want to do is something called FOIL. Which means I do my first times the first, outer times the outer, inner times the inner, and last times the last. So I'm going to start with the first item times the first item, x times x. Okay, I get x squared. Now we'll do the outer product, which means the 2 outside numbers, x and negative 3. I get negative 3x. Now I'm going to do the inner product, which is the innermost numbers, 2 times x. That's positive 2x. And finally, I will do the last terms, 2 times negative 3, which is negative 6. Now once I have done the outer and the inner product, or essentially any part of this binomial multiplication, I need to look for like terms. And you see that negative 3x and positive 2x both have x to the first power, which means that they are like terms, and I can combine the coefficients. So my answer will be x squared, negative 3 plus 2 is negative 1x minus 6. And now I've multiplied them together. That's just one way to multiply. There is a second way I can multiply, and I'll do that in example 4. In example 4, I have 2t plus 4 to the second power. I have a linear binomial, because there's 2 items that makes it binomial. It's linear because t is being raised to the first power. Now notice that this squared on the outside does not affect the degree of the binomial on the inside. That just tells me I need to square it. What does it mean to square something? Well, certainly it's not going to be 2t squared plus 4 squared. I can't distribute the 2 to the exponents like I usually do. That's because I have 2 terms in this binomial. 2t plus 4, and to square something means to multiply it by itself. So I take 2t plus 4 multiplied by 2t plus 4. Now here's the other way you can multiply. Some people like to use the lattice method of multiplication, so I can do that with this. I'm going to take the 2t for this row and the 4, positive 4, in the second row. And then the first column, I'm going to put the 2t from here and the positive 4 there. And now I'll just multiply row times column. 2t times 2t makes 4t squared. 4 times 2t, remember I'm doing this column by this row. 4 times 2 is 8. T times t to the 0 would just be t. This is also 8t, not 80. 8 times t. 4 times 4 is 16. You can see that that leaves 4t squared plus 8t twice plus 16. You can see that 8t and 8t are like terms, so they can combine to make 4t squared plus 16t plus 16. And that's all you have. So either one of these ways, the FOIL method or sort of the lattice box method, will get you the same answer. I'm going to do one of each method in this slide. In example 5, I'll use the FOIL method. And again, I'm just going to keep it color-coded for now so that we can keep track of the multiplication I am doing. Now in the future, you can just refer to this as multiplying binomials together, or binomial expansion is what some people call this. But it still requires multiplying the first terms together, 6x squared, the outer product together, 3 times 3x, which is 9x, the inner product together, which is negative 4 times 2, negative 8x, and the last product, negative 4 times positive 3, which makes a negative 12. Combine the like terms, and you're left with 6x squared plus x minus 12. It's a positive 9 and a negative 8, so that makes 1x. I'm going to do the lattice or the box method over here in example 6. All right, so I'm going to use the y for the first row and the 7 for the second row, so y plus 7. And up here on the columns, I'm going to use negative y minus 2. And I'll multiply the products together row by column. Negative y times y, negative y squared. Negative times a positive makes a negative. Y times y makes y squared. Negative 2 times y, negative 2y. Negative y times 7, negative 7y. Finally, 7 times negative 2, negative 14. Write them all down below. I have negative y squared minus 2y minus 7y. Does order matter? Do I need to put the negative 2 before the negative 7? It shouldn't, right? Because I'm adding. So I have negative y squared minus 9y minus 14. There you have it. Two methods, both will work. I could have FOILed on example 6 if I wanted to. You can use whatever method makes the most sense to you. In example 7, you see that I have another monomial times a quadratic trinomial. So I'm going to use a similar strategy to what I did at the beginning of the lecture and distribute out each term. Constant times the constant, or in other words, the coefficient multiplied by the coefficient. Negative 12x to the 4th power when I add those together. Negative 4 times positive 2 is negative 8. X squared times x is x to the 3rd. Negative 4 times negative 3 would be positive 12. X to the 2nd times x to the 0 is just x to the 2nd. And there I have it, no like terms. I'm completely done. Now finally, example 8. I'm going to recommend we use the lattice method for this one. But you notice that it's not two binomials. I have a binomial and a trinomial. In other words, I have 2 terms in the first parentheses and 3 terms in the second parentheses. So in the rows, I'll have 2 rows. 1 for each term in the binomial. Now 3 columns. 1 column for every term in the trinomial. And notice I keep the signs with them. And it's as simple as going through multiplying row by column. X times 5, 5x. X times 3x, 3x squared. X times negative x squared, negative x to the 3rd. It stays negative because this is a positive 1 times a negative 1. That makes a negative. 5 times negative 2 is negative 10. Negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2x squared. Now we have to write all these out, and it helps if you write it out in standard form. So I'm going to look for the term with the highest exponent, and that's negative x to the 3rd. So I'm going to write negative x to the 3rd first. Then I'm going to look for like terms that have the next highest power, x squared, and I have like terms, 3x squared and 2x squared. That makes 5x squared. So positive 5x squared. Now I'm going to look for the next highest power, x to the 1st. 5x minus 6x is negative 1x, so I have negative x. And finally, the very last item of the box is negative 10, has no other like terms. And there you have it. I've multiplied a binomial times a trinomial. All right, that's all we have for the video today. Make sure to answer the summary questions, and I will see you tomorrow. Thanks.